Next, I would like to invite Robin. Robin is the CEO and founder of Huba Energetics. Huba is a company which is making carbon nanotube coated electrical transmission wires for reducing the resistance and increasing the conductivity, as well as reducing the losses. In KCB and other electrical transmission lines, there's a lot of losses which happens due to these transmission losses, and this is reduced by their novel material. So I would like to invite Robin for this presentation and Huba. Thank you.
Thank you, Rakesh, for the introduction. Myself, Dr. Robin John. I'm a faculty member at the Department of Physics, St. Joseph's College, Moolamattam. Now, I'm standing here to represent Huba Energetics LLP, which is a startup we formed at the incubation facility of our college. And the idea or the product which we are developing is carbon nanomaterial coated low loss wires for application in power grids. So those are my partners, Mr. Ajit and Prince K. Francis. And CBIC has supported us with a startup grant with the support from KDISC and Government of Kerala, KSCB, Energy Management Center, and so on. So there are many agencies which combinedly support us for this startup project. Next slide. Okay. Okay, thank you. So the problem we are trying to solve is the ever-present power loss in all electrical networks, the power grids. And the reported power loss worldwide is around 15 to 20%, irrespective of the whether it is developed country, underdeveloped, or developing countries. And the prominent reason for these losses, there are many, but the major ones are put down here. The one is joule heating. First one is joule heating, which every electrical graduate will tell us, which is I square RT relation. That is the heat lost when current passes through a conductor, which is squared up as a function of current multiplied by resistance and time. So this is a loss which we sometimes make use of in terms of heater as well as our iron boxes and so on. But in the case of power networks or grids, this is not a useful thing. This is actually harmful. And one way people counter it is by reducing the current and increasing the voltage by using transformers, by using the step-up transformers in order to maintain the power. Power is a product of voltage and current, and if you have to reduce current, we have to go up in voltage. When you go up in voltage, what happens is that there is another guy which is popping up, which is corona discharge, which is actually high voltage breakdown of air surrounding the conductor. So when you walk below any high voltage power line, you can always hear a buzzing sound. That comes from this thing called corona discharge. And wherever you have a wire going throughout the network or the power grid, you have both of these effects acting all over the network 24/7, 365 days. That means huge amount of power lost in these two effects. Another loss is from corrosion. And we are trying to address all of these three things in one solution. So when you take the economics of it, our KSCB, Kerala State Electricity Board, alone loses around 1,143 crore rupees annually. That is considering a loss of 10.32%, which is actually much better than most of the progressive countries. And if you can reduce that loss percentage at least by 1%, the amount that Kerala will be saving will be around 110 crores of rupees annually. So, when you consider the solution, what we are looking for are carbon materials. And it was reported worldwide that these carbon materials can have very varying different electronic properties based on their size, shape, and so on. Generally, when we talk about carbon, we always think black color. But as you can see from the slides, they are slightly different in color. So the color difference does not only represent aestheticity, but it represents electronic property. One of them is conducting, one of them is insulating, and the other one is semiconducting. So if you choose the right material to coat on top of the aluminum wire which we use for overhead power lines, we could actually improve the conductivity. So that's what our idea was when we pitched for CBIC platform back in 2003. So this is how the product will look like. We coat the aluminum wires with carbon coating with proper conductivity material and use it for transmission applications. And ours is based, I'm working in a college, and so our resources are limited. So at that time, CBIC was gracious enough to support us with a startup grant, and we worked on it, and we have come up with a material which is actually showing better conductivity than normal aluminum overhead power lines. So the solution has social impacts, of course. We know that it can deliver more power to the end user, and it can save quite a lot of money for the power agencies, irrespective of which state you are in. KSEB, 1% reduction in loss saves 110 crores. And think about the networks all over the country. It should be much more. And this is actually giving more energy for the end user, which actually have a huge impact on the carbon footprint for every one of us. And it can put those power agencies in profit line if properly utilized. So overall, leading towards carbon neutrality using nanocarbon. That is our motto. So these are the pilots done so far. So we have developed carbon materials with better conductivities, and those materials were clubbed with metals to form composites so that they can form a coating on aluminum wires, and those aluminum wires were properly coated with those materials. And as you can see on the right bottom corner, normally the aluminum wires which we use in overhead power lines have 61% IACS, that is International Annealed Copper Standard, which is actually a standard used for measuring the conductivity of high voltage lines. Actually, it is comparing those elements with annealed copper. Copper has a better conductivity. So normally aluminum wires which we use for overhead power lines have 61% value, whereas we have developed aluminum wires coated with our nanocarbon materials with 97% IACS values. And we are working on the economics of it. It's still in the lab scale. We are looking for fundings for further developments. And these are the timelines, as you can see. We have formulated the idea in August 2022. April 23 won the Clean Tech Challenge, and July 23 company incorporation, and November 23 our works started, because initially when we pitched for CBIC, it was on the idea stage. And April 24, composite is prepared, and at present, composite is coated on aluminum wires with better conductivities in the lab scale. But we are on work towards application. So these are our supporters. CBIC supports us in collaboration with ANERT, Kerala Government, Energy Management Center, KDISC, and of course I should thank my institution, St. Joseph's College, and our innovation ecosystem, Innovation Nexus, and I should thank Startups Valley Amal Jyoti College for some crucial supports, and NIT Calicut. And thank you all. Thank you very much. These are our contacts.
Thank you, Robin, for presenting about Huba and the innovative means by which you are trying to save crores of rupees for the KCB as well as other electricity transmission partners.